The sum and difference property says that if you want to find the derivative of something that has terms that you're either adding or subtracting together, you're allowed to just find the derivative of each term at a time. So we've learned all the different rules that we're going to learn in this section, right? The derivative of a constant is 0. The derivative of x to the n is n times x to the n minus 1. The derivative of c times f of x is c times the derivative of f of x, constant multipliers, multiply along. And if you've got the derivative of things where you're adding and subtracting, take the derivative of a term at a time. So those are all our rules. Now let's just kind of finish up all these problems. No matter what, always rewrite, if necessary, before taking the derivative. And we'll look at problems where we have to do that, right? But we've looked at some where we had that square root of the radical, but we'll look at other ones as we go along. So find f prime if I give you that f of x is equal to 5x squared minus 3x. So this is the first time we have something with more than one term. Well, you know what? We're allowed to do this a term at a time. So f prime of x is going to equal, well, if it was just this, again, I use my power rule. 2 times 5 is 10. X, 1 less, so 2 minus 1 is x to the first power. And again, I don't need to write that 1, but I can if I want to. Minus, well, wait, what's the exponent on x if there's no exponent there? Well, I know that exponent is equal to 1. Right? If there's no exponent, I know that exponent is equal to 1. So then I use my power rule. 3 times 1 is 3. X to the 1 minus 1 is 0. So I have f prime of x is equal to 10 x to the first minus 3 times x to the 0 power. But let's clean this up real quick. So we have 10 x again to the first is not necessary, so 10x is fine. And now anything to the 0 power other than 0 is equal to 1. So that's the same as 3 times 1. So as x to the 0, we don't need to write that, so that's just going to be minus 3. So the derivative of 5x squared minus 3x is just going to be 10x minus 3. Because again, x to the 0 is equal to 1, and my 3 times 1 is going to equal 3, right? So anytime you have x to the first power, the variable goes away when you take the derivative. Let's continue on. Let's find the derivative. Find dy dx given that y is equal to 4x to the fourth minus 3x to the 5 halves plus 2. Again, take it a term at a time. The derivative of 4x to the fourth, we multiply 4 times 4, 16x, raise it to 1 power less, so 4 minus 1 is 3. The next term, minus 3 times 5 halves, and again, if you need to, you can just grab your calculator to do that, but 3 times 5 halves is 15 halves. X to 1 power less, again, you can grab your calculator to do that, and 5 halves minus 1 ends up being 3 halves. Plus the derivative of 2, well, 2 is a constant, right? 2 is a constant, and the derivative of a constant is 0. So you don't really need that plus 0 there. I won't take off if you have it. So basically, we know that dy dx in this case is just my 16x cubed minus 15 over 2x to the 3 halves. What about number 13? Well, I have x cubed minus 4x squared plus 3 over x. This is the first time I've seen anything that's rational, and at this moment, I don't know what to do. Because what are my rules? My rules, the derivative of a constant is equal to 0. The derivative of x to the n is equal to n times x to the n minus 1. The derivative of c times f of x is equal to c times the derivative of f of x. Constant multipliers multiply along. And finally, we can take the derivative of a term at a time. This is the only thing that I know how to deal with. I don't know how to deal with division. I don't know what to do if I see that division there. Well, remember that I said that we would have to rewrite some of these things first. So if you don't end up looking exactly like one of these that I'm about to highlight, just a constant, x to the n, c times f of x, or f of x plus or minus g of x, you have to rewrite it first. You must rewrite this first. Well, how do I rewrite it? Well, in math, we are allowed to put every single term over the denominator. So we're going to rewrite this as x cubed over x minus 4x squared over x plus 3 over x. And now we're going to clean this up because we need to get it into one of those formats that I had highlighted above. Well, what is x cubed over x? Well, x cubed over x is x squared. What is 4x squared over x? Well, that's just going to be 4x. What about 3 over x? Well, again, remember, I need it to look like x to the n. I need to get this thing out of the denominator. How do I get it out of the denominator? Well, recall from algebra, 1 over x to the n is equal to x to the negative n. Or, in our case, if we have a number over x to the n, this is going to equal that number times x to the negative n. So, what's the exponent on this x right now that I have highlighted in blue? Well, there's no number there, so I know it's an implied 1. So if I rewrite this, this is going to be plus 3 times x to the negative 1. Because, again, we need to make it a negative exponent. I need to get it out of the denominator so I can take the derivative. So now, if I take the derivative, I end up with the derivative of x squared. Again, bring that constant multiple to the front. So this is 2. X to the 1 power less, 2 minus 1 is 2. Minus 4, x to the 0, because there's a 1 here. And again, eventually we won't write even x to the 0. We'll just know that the derivative of 4x is just going to be 4. Plus, and then we multiply here. Negative 1 times 3 is a negative 3x. 1 less, negative 1 minus 1 is a negative 2. Let's just clean this up before we move on to the next one. Again, x to the 0 is just going to be 1, so we ignore it. So we have 2x minus 4 plus a negative is just minus 3x to the negative second. So the derivative is 2x minus 4 minus 3x to the negative second. Now the back of the book might clean this answer up. You do not need to in this class. I prefer you do not clean up your answers. I prefer you don't try to get them with common denominators. You don't try to get rid of your negative exponents. You can place this answer into my math lab, and this answer is good enough on a test. I do not need you to simplify any of these. All right, let's look at number 14. Again, number 14 is not in the right format, but now I know what to do because anytime I have some exponent in the denominator, I can just use the negative exponent, right, to get it out of the denominator. And for 2 over t, I know that's t raised to the first power. So I can rewrite this as f of t is equal to 4t to the negative 4th minus 3t to the negative 3rd plus 2t to the negative 1st. Again, in order to get these out of the denominator so that I can take the derivative, I write them with negative exponents. Now it's time to take the derivative, so I know that I need to use my power rule. So negative 4 times 4, negative 16, t, raise it to 1 less. Negative 4 minus 1 is negative 5. Negative 3 times a negative 3 is a positive 9. T, raise it to 1 less. Negative 3 minus 1 is a negative 4. Multiply, negative 1 times 2 is a negative 2. Raise it to 1 less, t to the negative 1 minus 1, or negative second. So the derivative f prime of t is negative 16 t to the negative 5th plus 9 t to the negative 4th minus 2 t to the negative second. So now what we're going to do is look at different applications of this, and then we'll look at finding the equation of a tangent line. So let's look at what the directions are asking for numbers 15 and 16. So numbers 15 and 16 say, hey, look, given that f prime of negative 2 is equal to 1 and g prime of negative 2 is equal to 5, find h prime of negative 2. And this is just us using our properties. So h prime of negative 2 is what I'm trying to find. Well, in order to find h prime of anything, I first need to find h prime. So if this is h of x, h prime of x is going to equal, well, 2 is a constant multiple, right? 2 is 2 times g of x. It multiplies along. So it's going to be 2 times, well, the derivative of g of x is g prime of x. So this is just reminding you that constant multiples multiply along. So I have that h prime is equal to 2 times g prime of x. Well, the question asked us to find h prime of negative 2. So that says everywhere there's an x, instead of writing x, I write negative 2. So this is going to be whatever 2 times g prime of negative 2 is. Well, do I know what g prime of negative 2 is? I sure do. That's given. G prime of negative 2 is equal to 5. So I just need to figure out what 2 times 5 is. Well, that's 10, which means that h prime of negative 2 is equal to 10. We're going to do the same thing for the next one. I'm given that h of x is equal to 3 times g of x minus f of x plus 5. And again, I need to find h prime of negative 2. In order to find h prime of negative 2, I first need to figure out what is h prime. So the derivative of h of x is h prime of x. Remember, 3 is a constant multiple, multiplies along. The derivative of g of x is g prime of x. Minus the derivative of f of x is f prime of x. The derivative of a constant, just the number 5, is 0. So I really don't even need to write the plus 0. Well, do I have enough information now to find h prime of negative 2? I sure do. H prime of negative 2 is going to equal 3 times g prime of negative 2 minus f prime of negative 2. Again, I don't need to write my plus 0. So this is going to be 3 times, what's g prime of negative 2? Again, that g prime of negative 2 is 5. Minus, what's f prime of negative 2? Well, my f prime of negative 2 is equal to 1. So I have 15 minus 1, or 14. So h prime of negative 2 is equal to 14. Let's look at number 17. So number 17 is asking us to find f prime of negative 1, f prime of positive 1, the equation of the tangent line at negative 1, and the equation of the tangent line at positive 1, and the values of x where the tangent line is horizontal. So there's a lot of stuff going on in number 17. So let's do all of this together. So in order to find f prime of negative 1 or f prime of positive 1, I first need to find f prime of x. Well, I am given that f of x is equal to 2x cubed minus 24x. So I'm going to use my rules to find f prime of x. So f prime of x is going to equal 2 times 3, which is 6x. Raise it to 1 less. 3 minus 1 is 2. Minus the derivative of 24x. Remember, when it's just an x, it's got a power of 1. It's just going to be 24. Because it's going to be 24 times x to the 0, and x to the 0 is just going to be 1. So we have 6x squared minus 24. So now, let's find part A. Part A says, what is f prime of negative 1? So part A, f prime of negative 1 is going to be whatever 6 times negative 1 squared minus 24 is. Well, in this case, it's 6 minus 24, and 6 minus 24 is equal to negative 18. So f prime of negative 1 is equal to negative 18. Okay, well, what's part B? Well, part B is asking me for f prime of 1. So for part B, f prime of 1 is going to be whatever 6 times 1 squared minus 24 is. Well, 6 times 1 squared minus 24 ends up being negative 18 as well. So f prime of 1 is equal to negative 18. Part C wants the equation of the tangent line at x equal negative 1. Well, remember, in order to find that equation of the tangent line, we need two things, right? Because we're going to use y minus y1 is equal to m times x minus x1, point slope form. We need the slope of the tangent line at x equal -1. And we're going to need the point. We're going to need -1 comma f of -1. So do I already know what the slope of the tangent line is? I sure do. I found that in part A. So the slope of the tangent line for the point -1 is equal to -18. So all I need to do is find out what the ordered pair is, and then I'm done. Well, how do I find the ordered pair? Well, I need to find f of -1. Well, what is f of -1? Well, recall, the given equation is 2x cubed minus 24x, so f of -1 is going to be whatever 2 times -1 to the third minus 24 times -1 is. Put that in a calculator, hit enter, and we end up with the number 22. So f of -1 is equal to 22. I now have enough information to find the equation of the tangent line. So I say y minus y1 is equal to m times x minus x1. We're going to solve this for y. First, a minus a negative here is going to end up being positive. So I have -18 times x plus 1. Distribute your -18, and you get -18x minus 18. Add 22 to both sides, and the equation of the tangent line at the point x equal -1 is -18x plus 4. -18x plus 4. Well, part D said do the exact same thing, except for now we're going to find the equation of the tangent line at x equal 1. Part D, the equation of the tangent line at x equal 1, I needed the slope of the tangent at x equal 1. Well, do I know what that is? I sure do. It was equal to -18. So then I just need that ordered pair, +1 comma f of 1. So I know what this is. I just need to find f of 1. So f of 1, again, you're plugging that into your original function. It's going to be, grab that calculator again, 2 times 1 to the third minus 24 times 1. And 2 times 1 to the third minus 24 times 1 is -22. So f of 1 is equal to -22. So then we put it into point slope form. So y minus y1 is equal to m times x minus x1. So a minus a negative over here on the left is y plus 22. If I distribute my -18, I get -18x plus 18. Subtract 22 from both sides, and y is going to equal -18x minus 4. So the equation of the tangent line at the point x equal 1 to this function is -18x minus 4. The very last portion is asking us to figure out where you have a horizontal tangent line. So part E. Anytime you're asked to find horizontal tangents, what you need to do is you need to figure out where is m tangent equal to 0. Well, how do you do that? You will always set the derivative equal to 0 and solve for the variable. Set the derivative equal to 0 and solve for the variable. So what is f prime in our case? What was that again? Remember, f prime of x is that 6x squared minus 24. So in order to figure out where we have horizontal tangents, we're going to set 6x squared minus 24 equal to 0 and solve for x. So if I add 24 to both sides, I get that 6x squared is equal to 24. If I divide both sides by 6, I get x squared is equal to 4. Taking the square root of both sides to solve for x, I end up with x is equal to plus or minus 2. So it wanted the values of x. I'm going to scroll back up. The values of x where the tangent line is horizontal. So the values of x where the tangent line is horizontal is at x equal +2 and x equal -2. That's it for section 2.5.